This is TechSNAP, episode 374. Hi, everyone, and welcome to TechSNAP, Jupiter Broadcasting's weekly systems network and administration podcast. We recorded this episode on July 12th, 2018, and it's brought to you by our three great sponsors, iXsystems, DigitalOcean, and Ting. I'll tell you more about them in a moment. My name is Chris, and joining me every week is my co-host, the admin, the teacher, and the presenter. It's Mr. Payne, Mr. Wes Payne. Hello, Wes.
Hello, Chris. It's wonderful to be back with you.
Wes, it's great to be back with you as well. I'm super glad you're back from traveling. You're back, and I'm actually traveling. I'm down in Texas, but that doesn't stop the TechSNAP show from rolling on. We've been doing our research, reading up on our stories, and we have a lot to get into. So let's warm up with a story that it would be mind-boggling if it just wasn't so common. Hackers managed to get into a military base and steal documents about drones and other things simply because of a misconfiguration.
It is all too common, Chris. A hacker is selling sensitive military documents on an online hacking forum. Some of the sensitive documents put up for sale include maintenance course books for servicing the MQ-9 Reaper drone, various training manuals describing common deployment tactics for improvised explosive devices, or IEDs, and the M1 Abrams tank operation manual, a crewman training and survival manual, and a document detailing tank platoon tactics. Not exactly the things I assume the military would like to have just leaked all over the place.
No kidding. And what's sort of amazing is the attacker was only expecting about 150 to 200 US greenbacks for this data. Not like some massive score here.
I mean, that's low enough. I almost want to pay for it right now.
He's only kidding.
I mean, you got to be curious, right? I'm curious.
I know what you mean, though. It is like, wow, just for a little educational experience. And that's, I guess, what the people at Recorded Future figured. They were some quote unquote intelligence researchers and, researchers that looked into this, and they actually engaged in a dialogue with the attacker to figure out how he did all of this.
Yeah, they discovered that he used Shodan, of course, to hunt down specific types of Netgear-branded routers that use a known default FTP password. The hacker used this password to gain access to some of the routers, some of which were located in military facilities.
Oh my gosh. So this is one of these things where you just shake your head and go, what was Netgear thinking?
Right? I mean, it's almost too easy. It's too simple. Once you know that it exists and it hasn't been updated, especially for some of those older routers that just aren't that easy to update or maybe don't have automatic updates turned on, they're just sitting targets.
So we're talking about the Netgear Nighthawk R7000, which is a really great name. But what's not clear, and we've checked several different publications and source material, is how he moves from FTP to getting inside the network, because it's believed he extracted the documents from a captain's computer, not from the router itself. However, it's possible that the router was using the USB sharing function or something like that. So if we get more details on that in the future, we'll include that because it seems like a pretty key piece of the story. But essentially, he gets on the router using the default FTP username and password and moves from there.
Yeah, exactly. Another case of island hopping that we see so often, right? If you can identify one way to access a network frequently, that's all you need, and there's enough other vulnerabilities or access points floating out there that then you can jump around to wherever has the most interesting information.
Yeah. And it's just undeniable that this incident could have been completely prevented had maybe the base IT or whoever had set up the router just changed some of the defaults. Just defaults even. Why was it even turned on? And why didn't somebody go through it? There's such simple steps that could be taken to prevent stuff like this.
Oh, yeah. I mean, it's a little more excusable if you're a home network. But if you're a military network where presumably IT professionals are involved, it's a little unusual to be using a router like this at all, I would think. But if you are, then you really need to have some sort of system where you've cataloged what devices are on your network and if there are patches or updates or insecure configurations that become known, right? That's part of IT's job, is to stay up to date with the device software and hardware that is actually deployed so that you know. And in this case, we have known since 2016. Security researchers in 2016 raised the alarm about these FTP credentials. So there's been over 2 years of time to go and update. And all you have to do is log on to the admin page and set a secure password.
This really is why IT departments will often do one of those things that drives end users crazy, and that's have a list of approved hardware. So that way they can go through and test and verify these kinds of things. And if you buy off that list, then you have things like default FTP passwords. I'm not saying that happened in this case, but that really does help control things like this. Is you narrow the scope and you have a focused set of equipment that you test and verify against. And then you have to just, as the IT department, stay on top of that list, make sure you're keeping it current. But that really can solve problems like this. When it's left up to the users to implement Wi-Fi solutions or whoever did it, things like this will happen. When you deviate from a standard, things like this happen.
Well said.
But kind of along these same lines, but on a much, much larger scale, it looks like a bunch of old routers that have been deployed by ISPs, if we're lucky, could be receiving some updates for old critical vulnerabilities.
Yeah, patches for 3 critical vulnerabilities impacting broadband gateways made by Advanced Digital Broadcast, or ADB, have been released to the public nearly 2 years after the bugs were first found. Issues range from a privilege escalation flaw, an authorization bypass vulnerability, to a local jailbreak bug. Switzerland-based ADB manufactures routers and modems for over 24 broadband communications firms distributed globally. The company also counts North America's 3rd largest ISP, someone you may have heard of, Cox Communication and Charter Communication, as customers. Neither Cox nor Charter returned inquiries on, how many of these might be deployed, so we can't really speak to that. But clearly it actually has real world deployments, and that means it matters. Interestingly, one of the 3 critical vulnerabilities, in this case it's CVE 2018-13108, is a local root jailbreak bug that can be exploited thanks to a network file sharing flaw. So that's your connection, right? I mean, network file sharing, while super useful on a LAN, it's just inherently dangerous. And if you're not actually using it, it's just not something you should have enabled.
Really has no place on an edge device. I've never liked this trend of adding USB ports and Samba file servers on these edge devices. It's always seemed like a source of hurt. And then when you combine the fact that they're very poorly maintained, it just seems like implementing all of the worst concepts of security in one box.
Right, like the thing that's doing the firewall should also not be the thing that's sharing files to everything on the device. It's just too close for comfort.
Yeah. And the thing that you maybe update once a year if you're being good, maybe not the best place to be running a file server, even if it's quote unquote only on the LAN. I don't like it.
To make matters worse, these broadband gateways were also vulnerable to a privilege escalation flaw via Linux group manipulation that could basically allow an attacker to gain access to the command line interface even if the ISP had been taking reasonable precautions and had disabled that command line access. So there's a lot going wrong here.
The Timehop service was recently breached. That's not too unusual, but things took a bit of a twist when after they made the announcement, they had to come back and say, oh, sorry. Turns out, much worse than we initially thought it was.
The company first acknowledged the breach back on Sunday, saying that users' names, email addresses, and phone numbers had been compromised. But now it's saying that additional information, including date of birth and gender, so a little more personal there, was also taken. Now, to be clear, Timehop isn't saying that there was a separate breach of its data. Instead, the team has discovered that more data was taken in the already announced incident.
That's horrible. So they got a little ahead of themselves, it sounds like.
Yeah, to quote them, "In our enthusiasm to disclose all we knew, we quite simply made our announcements before we knew everything. With the benefit of staff who had been vacationing and unavailable during the first 4 days of the investigation." Oh, I know what that's like.
Yep.
And a new senior engineering employee, as we examined the more comprehensive audit of the actual database tables that were stolen, it became clear that there was more information in the tables than we had originally disclosed. Now, that's not ideal, but I can see how that might happen.
Yeah.
Because, I'm sure at first you're just trying to gather information. You ask someone, there's a subject matter expert. You're like, well, what's in that table? What's in that? And people just make mistakes, especially in high pressure situations.
Yeah, and you're trying to go quick, trying to get all the information out there, because one of the things people always will say is, oh, they had a quick response. So now everybody's trying to have a quick response.
Exactly.
Now, the pressure was off a little bit because the team noted that the service does not have any financial information from users, nor does it perform like detailed behavioral tracking. So they didn't have like a bunch of that information in the database. Really, even people's memories, that's what the Timehop service does. It goes through and captures memories from social media. Those were in a totally different spot, uncompromised.
How did this all happen? Well, the breach occurred when someone accessed a database in Timehop's cloud infrastructure that was not protected by two-factor authentication. Now, the company insists that they were already using two-factor quite broadly. This database, it seems, just sort of fell through the cracks. Now, that's not great, but it is at least nice to see that they acknowledge that two-factor authentication can be a key component of a well-rounded security architecture, so hopefully this means they'll do a little more thorough auditing after this breach.
Yeah, and it's always the one that falls through the cracks, isn't it? It's always how it goes. You get things all set up, and then somebody compromises the backup server or something that didn't have the two-factor authentication.
And I think that's really what's changed in recent years, right? Is before, the sort of pressure on those systems was low enough that the probability that that was going to happen was reasonably low for, non-large target organizations. But these days, with the dangerous internet that unfortunately we have in 2018, you just can't assume that. There's enough attacks all the time, enough people who find some small financial incentive in attacking you that you really need it everywhere.
Mm-hmm. Now, they do say that a small percentage of their cases were records that did include full names and email addresses, phone numbers, date of birth, and other things that may be more identifiable. So it's unlikely that many profiles had that, but some did. And they suggest that those users perhaps should, quote unquote, protect themselves by password protecting their services, maybe doing credit management and things like that, as is the standard answer that you always get.
Yeah, exactly. And, you can be a little defensive here if you have one of those email services where you can use different or modified email addresses for different accounts. And then, of course, you should be using a password management service of some kind, or at least using different passwords for different sites and for different security domains. So don't let this happen to you.
Researchers have uncovered new types of attack against LTE mobile networks.
Security researchers from Bochum and New York universities have developed 3 new attacks against LTE technology that allowed them to map users' identity, fingerprint the websites that users are visiting, and, worst of all, redirect them to malicious websites by tampering with DNS lookups.
Wow. So, and to be clear, these are separate from the other types of issues we've covered on the TechSNAP program, even in the last few recent months.
Turns out security is hard in wireless networks. All 3 attacks abuse the data link layer, aka layer 2 of the LTE network. Now, you can find out a little more detail if we don't have enough here. They've got a more detailed site set up at alter-attack.net. But to get into a little detail, the data link layer lies on top of the physical channel, right? So your cell phone joins the wireless network, it attaches to a base station, and then you start sending layer 2 packets. You can think of this as Ethernet on your home network. It's responsible for organizing how multiple users access resources on the network, and it's what is the base network that lets you set up a higher level layer 3 IP-based network and actually start, talking on the internet. Now, the first 2 attacks described here are really passive attacks, right? So you can do identity mapping. That means if you have access to this traffic, you can map and watch users as they migrate around base stations and be able to reliably identify a particular user using a cell network. That's not great. Once you've identified them, you can also use these techniques to do website fingerprinting. So you can actually go see and identify, assuming you can map the fingerprints correctly, you can then go and see and work out that they're visiting certain sites. So if you're trying to spy on a journalist and you're trying to prove that they're accessing some sort of, resource you don't want them to be or that you think they shouldn't be, this would allow you to do that. The third attack, dubbed Alter by the team, is actually an active attack. So this would allow the attackers to perform man-in-the-middle attacks, intercept communications, and alter them. In particular, this has allowed them to change DNS answers. So you go and ask for the DNS lookup for a particular website. Assuming this attack can be applied successfully, they can return a malicious response and redirect you to another site.
Yeah, what surprised me about this, though, is that it's capable of doing this even though the LTE network is encrypted.
Yeah, exactly. And so it turns out that Alter exploits the fact that LTE user data is encrypted in counter mode, AES-CTR, but it's not integrity protected. And that's key because it allows them to modify the message payload. The encryption algorithm is malleable, so the adversary can actually modify the ciphertext into another ciphertext, which later decrypts to a different but related plaintext. And that's why you really, it turns out that, this is a hard problem. And to be fair, LTE has been around for a long time, but it just shows again that the more incentive attackers have to do this, the stronger vigilance we need to have as people implementing these systems.
The researchers had a proof of concept that they were demonstrating, and there is a link in the show notes to a video. It shows an active attack that could redirect DNS requests and perform DNS spoofing attacks, causing the victim mobile device to use a malicious DNS server that eventually redirects the victim to a malicious site that, in this case, was masquerading as a fake Hotmail site.
Sounds scary. Now, while that's true and it is very dangerous, we should note that the researchers think that currently it is pretty difficult to perform in real-world scenarios. Now, it requires about $4,000 worth of equipment, which really isn't much for a targeted attack, but it also requires some careful setup and, advanced knowledge of a victim that you're actually trying to interfere with. And it probably only works, at least so far, within about a 1-mile radius of the attacker. So there's a lot of qualifications here, but if you are a particularly sensitive individual, someone like a politician or a journalist, those might be very easy obstacles to overcome.
And it appears that the forthcoming 5G mobile standard will not fix this issue, and there's not really a great solution to retroactively fix it and the existing LTE networks.
This is one thing I think we really should be talking about, especially as we're developing the next generation of networks, because especially, at least here in the United States, there are not that many carriers, and a lot of what they do happens in the backbone, and we just, as consumers, we don't really get to see that. And that means we don't really get to select on that. How often, do you choose your cell carrier based on the security of their LTE network? No, you don't have that information. It's not presented to you. It's really not on your thought process, but it probably should be, because as long as this all stays private and behind closed doors, we're not going to see much change.
So I guess with all that in mind, are there steps that the audience or I could take to protect myself?
A little bit. So the researchers identified a couple things that could be done on both sides to help going forward. And first of all, that's updating the specification. They called for all carriers to band together to fix this issue by updating the specification to use an encryption protocol with authentication, something like AES-GCM or CHA-20 Poly 1305.
Sure. I'll get in behind that.
They're already deployed in other contexts. There are real-world use cases they can learn from. It's not like they have to invent how to use this stuff in production. There are experts they can hire, consultants they can use. Make it happen. That would be awesome, and it would be a real-world security benefit.
Yeah. All right. Okay.
For the end user, or at least for services that, are not actually the ISP, HTTPS, and in particular, HTTP strict transport security can act as an additional layer of protection, helping prevent the redirection of users to a malicious website. Now, that doesn't work, and there are some caveats about HSTS that might not make it always a good idea, but it does show that we really do need to be operating in a security paradigm where we don't necessarily trust the networks that we traverse through our ISP on the way to the global internet.
Right. Yep. So make sure it's using SSL, HTTPS, every website that you can, and use a VPN when in doubt.
Exactly.
In episode 365 of your TechSNAP program, we told you about this hack for the Nintendo Switches that was essentially unfixable, at least on the units that were out in production. Nothing Nintendo could do because it was at the hardware level. Well, now, 9 episodes later, we reportedly have a fix that's being rolled out kind of on the DL by Nintendo.
The report comes from prolific Switch hardware hacker Cyrus M, who writes that at least some Switches currently on retail shelves are not vulnerable to the cold boot exploit known in hacking circles as fusée glee. Cyrus suspects that Nintendo has used the iPatch system on the system's NVIDIA Tegra chip to burn new protective code into the boot ROM, cutting off the USB recovery mode overflow error that we previously talked about. These boot ROM patches are relatively simple for Nintendo to implement in the factory when the system is manufactured, but as we talked about before, they are impossible to load onto the tens of millions of Switch units that were already sold. Now, Chris, you've got a Switch pretty recently. Do you know, is yours patched?
That was the first thought that crossed my mind when I saw this story. I got that Switch just, 7 days ago before my trip down here to Texas. So it's possible it's been patched. It's back at the hotel room right now. I think the first thing I'm going to do when I get back there is check its firmware version.
Yeah, that's a good thing to do. The newly protected Switch hardware is reportedly loaded with firmware version 4.10, which has actually already been outdated since the release of version 5 in March. That suggests that these units are not actually supporting a new, more secure version of the Tegra chip, but they're just running a different firmware.
So if I have version 5 of the firmware, I'm likely good because they've only put the fix in the older version, which is kind of funny. So if I have a newer firmware, I'm in the clear?
It looks that way, at least at this time. It's a little complicated because the older firmwares are even still vulnerable to a different software level exploit method, also developed by CyrusM, called Deja Vu, but that one has been patched in the 5 series. Now, of course, these firmwares are just binary blobs, so they can be a little difficult to analyze, and until we see a little bit more actual testing of these retail switches, I think we'll need more information.
Well, hopefully mine is still hackable, and if it is, I probably got it in just under the wire. If you've been on the fence, this might be your opportunity to just pull the trigger and get the switch now, because if you want to be able to hack it at all, ever, you better make the move.
And as always with hardware hacking, well, if you want to be able to hack things in the future, you do have to play a little bit of a risky game, and that is don't update your firmware. Now, that means you probably won't get any sort of security fixes. Maybe that matters a little bit less with something like a gaming console, but the lower you can keep your firmware version, the more exploits you'll remain vulnerable, and that might mean you'll have hardware access to the device at some point in the future. But if that's not enough information for you, you want to learn more, go check out our show notes, techsnap.systems/374.
Let's take a moment and thank DigitalOcean for making the TechSNAP program possible. do.co/snap. That's a special offer where you can get $100 in credit when you sign up with a new account. DigitalOcean is infrastructure on demand. Get deployed in less than 55 seconds. Everything is using SSDs, every type of rig that you deploy. 40 gigabit connections coming into the hypervisor. A fantastic, beautiful, I'm going to say it, beautiful interface to manage all of it. It's simple as well, and it has a fantastic API that goes along right with it, well documented, super easy for you to implement in existing projects. They have industry-leading price to performance as well, and predictable costs, which as a small business, I really appreciate. They have optimized compute types. You can choose from standard or CPU optimized droplets, and you can customize from there. My favorite system is 3 cents an hour. They have systems that are just as low as $5 a month. They also have systems, one that I'm experimenting with right now, that have super fast dedicated CPU cores that are really fast. I encode a lot of video, and I can tell you some of the fastest results I've ever seen are on these DigitalOcean systems. And then you combine it with their enterprise-grade SSDs, the 40 gigabit connections, data centers wherever it's really best for you. They have locations all over the world. And then the fact that I can easily work with a team, it's really unstoppable. And DigitalOcean just loaded a whole bunch of more tutorials on their website. About 14 minutes ago, as I record this, they just put up a whole bunch of new guides. Everything from optimizing MySQL to getting started with LVM. It's a whole range of stuff. In fact, scrolling through the backlog, it looks like they've been doing this for days. Lots of great documentation. There's tons of one-click deployment applications. DigitalOcean is great. So go try it out with a $100 credit when you go to our URL, do.co/snap. Also, an enormous thank you to iXsystems, iXsystems.com/TechSNAP. Go there to support the show and learn more about iX. They'll build a solution around open source that's perfect for you. And let's be honest, I have this problem. We all have this problem. It's our data. It continues to grow, and preserving it is becoming more demanding than ever. Protect your enterprise storage environment and save time and money with a TrueNAS unified storage array. It has built-in security and protection from OpenZFS. It comes with Intel great powerful Xeon processors. It has HIPAA compliance, PCI DSS compliance, and GDPR compliance, which is very good for a lot of you out there. The enterprise version of FreeNAS. It's TrueNAS, and they're the company behind both of them. You hear all these great things about FreeNAS? Check out TrueNAS. They also sell the FreeNAS Mini, which is a fantastic solution for a small business or home office, and it is a champ. As somebody who had one in production for years and years and years, only to be finally replaced by an even larger FreeNAS. It's a fantastic product, and they have award-winning white glove US-based support. They're fast, and they'll work with you to implement whatever open source solution you need. Check them out. iXsystems.com/TechSNAP. There's a white paper there you can download and learn more. They also will post recaps from community events, and they have an update on their NASs. Check it out on their blog, but start by going to iXsystems.com/TechSNAP. No other hardware provider I recommend. It's only iX. iXsystems.com/TechSNAP. And there is an outrageous shout out to Ting for a long, long commitment to the TechSNAP program and for keeping me connected while I'm traveling. Go to techsnap.ting.com. That'll take $25 off a device if you want to grab one from Ting, or if you bring a device. And Ting has CDMA and GSM, so they got a lot. You can check their BYOD page. If you bring a device, they'll give you $25 in service credit. Now, it's just mobile that makes sense. It's smarter than unlimited because if you use less, you pay less. If you don't make a lot of phone calls, why would you pay for minutes? It's a scam. If you don't get a lot of text messages, why would you pay for text messages? If I'm on Wi-Fi, why am I paying for my data? That doesn't make any sense. If you think about it, you've been scammed into a system that these duopolies completely control, and Ting is shaking the whole thing up. The average Ting bill is $23 per phone per month. It's easy. It's $6 a month for the line, and then your minutes, your messages, and your megabytes. Whatever that adds up to, that's what you pay, plus Uncle Sam's cut. They got nationwide coverage, no contracts, no early termination fees, and of course the entire time you're in control. They've got a control panel that's on the web, also in mobile apps. It's great. You can see your usage at a glance, take complete control of whatever aspect of your account, turn something off, turn something on, and you can set usage alerts as well. They have every device you'd come to expect. They have a great support staff, really great people. They're phone geeks that like talking to customers. It's a revolutionary concept. I don't know why Ting was the first one to think of it, actually. And they have a blog that, again, I always go to for resources throughout the week. This week, they just posted their guide to the best streaming TV services for traveling. And you look at that and you go, what? And let me tell you something. Right now, as I'm living out of a hotel room, this is a particularly odd thing to try to work into a traveling life. I don't really know how to describe to you how weird it is to leave your home with all of your services and all your stuff and be transplanted into a hotel room and have access to none of it. So to have Ting go through here and kind of describe how to use this stuff and how it would work while you're traveling, man, they just nailed the timing on this one for me personally. So I wanted to give it a mention for you too, in case it might be applicable to you when you're traveling. So to check that out and much more, get started by going to techsnap.ting.com. That's techsnap.ting.com.
If you follow the tech news and you manage to filter out all the hype around the cloud and machine learning, another trend has really stuck out lately, and that's quantum computers. And in particular, there's been a lot of concern about the implications of quantum computers being available to the public and what that might mean for cryptography. Now, most of these stories have been about possibly dire implications, but I stumbled onto a blog post over at the wire.com blog that shows they've been doing some proactive research to defend against a post-quantum world.
For those of you not familiar, Wire is a secured messenger, and they are really well respected within the crypto community. And so we kind of keep tabs on their blog from time to time just to see what they're thinking and talking about.
As they note, today's encryption protocols are mostly not resistant to quantum computers. Now, fortunately, right now, quantum computers don't really exist in a way that can take advantage of these vulnerabilities, but as research advances, that time is coming. It's important to note, though, that a quantum computer is not just some sort of magic computer that is running at a higher frequency or just in some way faster than a classical computer. In some cases, it's actually slower. But thanks to some completely different ways of actually computing values, it can solve some problems in a fundamentally more efficient way than any classical computer. This is called the quantum speedup, and the National Institute of Standards and Technology, better known as NIST, has compiled a giant list of problems that could potentially benefit from this. And the first two on that list, basically factoring large numbers and computing solutions to this discrete logarithm problem, are practically impossible to solve unless you've got a large enough computer. And in particular, those are precisely the things that make a lot of public key and other encryption algorithms possible. So, factoring, that is a huge basis. Basically, the hardness of being able to factor a large number in a quick amount of time is basically what makes things like RSA secure. And on the flip side, we've talked a little bit about elliptic curve technology, and that relies on the discrete logarithm problem in exactly the same way. It's easy to come up with a valid solution, but to work backwards from that problem to actually solve for the initial inputs and be able to get the output back, that's very difficult for classical computers, and it just takes so long that you can't meaningfully make an attack if you've chosen big enough keys.
So with quantum computers, my understanding is they are particularly better at solving those kinds of problems, and the amount of power they have is measured in qubits. I'm pretty new to all this, but how does that work, Wes?
Yeah, in a classical computer, you encode information in bits, right? We talk about bits, we talk about bytes in particular, which are 8 sequences of 8 bits. And we model basically all information as binary values. So each bit can take on a value of either 0 or 1. And in hardware, these 1s and 0s act as on-off switches that ultimately drive the computer functions way down in the silicon and the CPU. Quantum computers, on the other hand, are based on qubits, which operate according to 2 key principles of quantum physics. And this is really where it gets different. Those two principles are superposition and entanglement. Superposition means that each qubit can represent both a 1 and a 0 at the same time, and in particular, it's a combination of both of those states. Entanglement means that qubits in a superposition can be correlated with each other. That is, the state of one qubit can depend on the state of another. And using both of those facts, qubits can act as basically more sophisticated switches that enable quantum computers to function in ways that can solve these difficult problems that are just basically physically impossible for today's classical computers. Now, to get into that a little bit more, quantum computing is based on the fact that in the microscopic quantum world, things don't act in the clear-cut way we expect from the macroscopic world that we experience. Tiny particles, like electrons and photons, can simultaneously take on states that we would normally deem mutually exclusive. So that means you're not in the 0 position, you're not in the 1 position, you're in some combination, right? And the way it ends up working is the time evolution of these quantum states. The system changes the probability that you'll find it in one state or another. So to correctly model the system, you actually have to treat it as a superposition. It's not a 0 or a 1. It's a little bit of a 0. It's a little bit of 1. And the ratio and proportion between those changes as time goes on. But when you actually go eventually take a measurement of the system collapses and you'll always find it in one of those 2 states. But you have to describe it as a superposition, as a combination of those states to actually be able to reproduce results from the physical world. So there's the famous Einstein quote, God does not play dice. But it seems that in our weird world that quantum mechanics describes so well, there is this sort of fundamental probabilistic aspect to it. And where that really comes into benefit is that superposition frees us from binary constraints. A quantum computer works with particles that can be in superposition. So rather than representing bits, they're qubits. And when you try to do something to a quantum system, it's though you're acting simultaneously on both 0 and 1.
So yeah, that would give quite the speed up.
Now, here's a little bit of an interesting example I find, and you can read more thoroughly in it in the show notes, but imagine a line of people waiting at the gate to a nightclub, right? And there's a sort of mean bouncer at the front, and in this case, he's only going to let in 8 people. That means we can represent each of these people with a unique binary number, right? Basically 0 to 8, or 0 to 7, encoded in binary. So person 0 is 0, 0, 0, person 7 is 1, 1, 1. Now, the bouncer writes this down in a particular way, basically with a bit string. So, you can just use one byte that has enough space, and you can put a 1 if you're going to let in that person, or a 0 if you're not going to let in that person. Now, for this example, you don't know if the bouncer is going to decide what the bouncer is going to do to each individual. You just can't predict that. But you do know what his general preferences are. And it seems like he basically always either lets everyone in, or he's going to let exactly half the people in. So on a good night, he just lets in the really attractive people, and on a bad night, he lets everyone in, and it's a worse experience. Your task is to not find out what happens to each individual, but basically, based on some information, can you determine if the bouncer's in a generous mood or not? Does he let in half the people or all the people? And the question is, how many lookups do you need to do to find out which world you're in, either in the generous or the stingy? If you're using a classical computer, then in the worst case scenario, you'll have to look up 5 times, right? Because even if you see a 1 allocated in the first 4 parts of the bit string, you can't be sure that all the bit strings will be 1, right? There's still the possibility that it's only half of them. So you need to check that 5th value. And if it's a 0, then you know it's going to be half. And if it's a 1, then you can say, okay, well then all of these people are going to be let in. The difference with quantum computers is that you can look up the function value for all 8 people simultaneously due to the way qubits work. So you only have to do 1 lookup. For the cost of running the program once with this funny superposition stuff, you've basically computed all the values at once. Now, the math behind this is a little complicated if you haven't taken a bunch of linear algebra, but it all works out. And the advantage of quantum over classical becomes even more apparent when there are more people. For a line consisting of 2 to the n individuals, a classical computer would need to look up 2 to the n minus 1 plus 1 times, a number that grows very quickly as you have a bigger n. A quantum computer, by comparison, only needs one lookup no matter the size of n. Sounds great, right? Now, unfortunately, there is this collapse trick of nature, and it makes things a little more difficult. You have these 8 simultaneously looked up values that will be encoded in the quantum state of your system, but you can't actually read any one of them by choice. Any measurement will disturb it, and it will end up collapsing, and you only get one of those values. But you're not really trying to find that out in this problem. What you want to know is whether the bouncer is feeling generous or grumpy. And that's just a simple yes-no question that ends up needing not that much information. So some famous quantum researchers were able to show that you can perform an extra operation on your quantum state, which teases the simple piece of information you want into just the right places so that once you measure it, you're very likely to read that measurement out of the system. It's a little bit like a house of cards that will collapse as soon as you look at it. You might never be able to really see it and understand it in its full glory, but if you construct it in just the right way, you may be able to ascertain some information about what it looked like before it collapsed.
That makes a lot of sense. That's a great explanation. So let's talk about where quantum computers are today. It looks like computers that could break today's cryptography do not exist. Physicists are experimenting with tiny quantum computers with fewer than 50 quantum bits, or those qubits Wes was talking about, and they're only able to run for microseconds. In comparison, Wire says that the system needed to compute the kind of discrete logarithms that are used in Wire or other cryptographic systems today, including SSH or TLS, would have to have millions of qubits and would have to run for days, perhaps weeks, not microseconds. So we're not there yet, but things change, Wes.
Right. And so, yeah, exactly. What's interesting here is given the properties of quantum computers, researchers have designed some novel algorithms that can take advantage of those properties and do things in a way that scales better. In particular, one example is Shor's algorithm, which lets you factor things in much faster polynomial time than you can do with a classical computer. But to date, the largest number factored is under 100,000, right? So that's nowhere near the size that you would need to make a practical attack on something like RSA. The point is, if the hardware technology keeps growing, then we know these algorithms will be able to scale with them, and that's where it gets dangerous. We're not there yet, but as you know, cryptographic systems take a long time to stabilize, a long time to prove, and a long time to get trust in if you're going to use them for anything meaningful, and that's why it is important that we start thinking about this now. Now, maybe it'll end up like so much technology that, it's not 10 or 15 years down the road, it's 50, but either way, this is interesting theoretically, and I'm sure, like all research, there'll be many gains to be had no matter how dangerous quantum computers actually become.
Yeah, and the folks over at Wire point out that there is a non-negligible chance that there could be some sort of breakthrough that leads to large, scalable quantum computers in the next 50 years. Now, they don't think it's a high chance, but it means that it can't be completely ruled out, just like you shouldn't rule out a natural disaster so you come up with DR plans. You probably should start thinking about this. And great point, Wes. These things take forever to roll out to the real world. They have a long process before they're set up on everyone's systems and all of the client systems as well. So it is a good time to start thinking about this. It looks like NIST is running a post-quantum cryptography project in order to standardize one or more post-quantum algorithms around 2020, 2022.
Yeah, I like that they're doing this, and I like some of the ways that they've set up this project because they see their role as managing a process of achieving community consensus in a transparent manner. So they don't expect to, quote unquote, pick a winner. Ideally, several algorithms will emerge as good choices. They may then pick one or more for standardization, but either way, we should have a number of algorithms that have been well researched, well studied, and that we can, at least within the next 10 years or so, feel that we could maybe trust against quantum computers. In particular, Wire is using New Hope, which is a lattice-based encryption algorithm that is one of the proposals that's been proposed to this NIST workshop. What's interesting, I thought, is that New Hope is lattice-based, and what that means is instead of relying on things like factorization or the discrete logarithm problem, they are instead just basically shifting the burden over to lattice problems. So, there's a whole mathematical theory of lattices, and it also has some problems that are hard for computers. And as yet, there are no known quantum algorithms that give this quantum speed up to those sorts of problems. And so those are being used as a basis for new cryptographic techniques. If you're curious, check out the show notes for a ton more information. Really, you can deep dive on this for days, if not years. And you can go check out the proof of concept implementation that Wire has. Looks like it's a Rust app that's just sort of, getting the ball rolling, trying to see what this might look like in actual practice.
Thanks for going to techsnap.systems/contact for sending us in your questions or your war stories. Love them all. And our first one comes in from Mr. M in Baltimore. He says, my work's upper management wants to get rid of all of our Linux desktops because they, quote, can't be managed. What they mean is that our MIS team can't admin them directly via our chosen MDM solution, which is AirWatch. Our entire fleet of Linux desktops are Ubuntu-based, and other than Ubuntu Landscape, which apparently doesn't meet our needs, we haven't found a solution for remotely admitting these machines. Do you have any suggestions that we can look into so we can keep our devs happy and coding on their Linux box? Thanks, M in Baltimore. Boy, it really is a shame I can't say the answer is Landscape, because Landscape is made by Canonical, it's baked in to Ubuntu, and it is a great way to at least manage packages and keep on top of security issues with Ubuntu. So I wish I could just say, suck it up and use Landscape. Because in a way, my answer would be you're kind of doing it wrong. If Landscape isn't doing what you want, then you may need to be managing these systems differently. And I kind of wish I knew what the requirements are. Is it application and security patches? And is there a reason that couldn't just be scripted and those kinds of things? Does anything come to mind for you, Wes, like a management solution for these boxes?
You're right. I think it is a somewhat difficult problem just because there are sort of different ways of thinking about how you manage those types of systems. And I think a lot of times, especially in the big IT space, people just reach to a vendor and you're like, oh, yep, here's your solution for Windows. It does all these things and you can check off these boxes that you have to fill out on forms that lawyers ask you or whatever other compliance things you need. But what you really want to understand is what are your threat angles? What are you actually trying to defend against? What do you need to manage? And there's a ton of different solutions for all of those, right? You should probably already have some sort of network level security, IDS systems, firewall policies, things like that. And then are you giving your users root? Are you providing images? There's a lot of things you can do just with configuration management to enforce policies. And then maybe you have some sort of system to run something like InSpec or other solutions that you can run against those machines to determine if they are in compliance and produce reports about those systems. And maybe that's enough. If you need a little bit more heavy-handed, then probably you won't be able to give your users sudo or at least full root access and maybe constrain them to be able to run a couple of the programs that that they'll need, a web browser, a terminal with SSH, but without root. Maybe that's enough, in which case that's a little simpler.
Yeah. I think my opinion on this is keep your machines in a good state, be aware of what they're doing, make sure they're patched, audit them if you need, but your network security should not depend on the security of your end systems. It could play a role and it could help be preventative, but it shouldn't be dependent on your end systems being super, super perfect, because that's never going to happen. All right, well, let's do an OpenStack question, Wes.
Our listener writes to us that he's moved up in his career from a typical help desk and support role to sysadmin and now to more of a developer support / DevOps role. Knows his way around AWS, Tomcat, Apache, Nginx, Java, Python, and a few other tools and languages. However, when trying to dive into the systems side of things, he writes that I get a bit lost and don't know where to begin. Some examples include things like OpenStack, compiling my own kernel and actually using it, Terraform, and LXC. What resources would you recommend for diving deep and learning this material? I know Linux Academy has a ton of courses on OpenStack, which I do plan on checking out, but the OpenStack documentation seems, scattered? I'm not sure if that's the right word. It seems very detailed, if not overly verbose. Also, another side note, I know that Docker has a great platform for hosting and running Linux containers, but as with AWS to OpenStack, I want to really understand infrastructure as well as containers with LXC. Now, the answer may be just sit down and read it. If you don't understand it, reread it. And if so, I accept that, and, I might just need to do that. Sorry for the long letter. Thank you so much for your time. I understand if you can't answer this on the show, but hey, turns out we will. So thank you for writing to us, and hopefully we can give you something that will actually be useful. I'll let you take it first there, Chris.
Yeah, I have to say, I am here at Linux Academy today, and they launched new OpenStack courseware today. and they're working on additional OpenStack and OpenShift courseware right now. So it is a really good resource. Just as a little plug, they don't sponsor TechSNAP, but I think it'd definitely be worth you checking that out. Because they also have like hands-on versions where you can actually deploy it. They'll set up an entire OpenStack instance for you. And the other thing that's really nice is so they'll let you jump ahead. So maybe you don't need to learn how to set up Linux. You can just jump right ahead. So I'll give that a plug. But I would also say, OpenStack is extremely verbose in its documentation. I would agree with your assessment there. I would find other documentation. So perhaps go set up a VPS OpenStack instance and read their documentation as an example, like DigitalOcean's, another plug. But that's a great way to go hands-on and learn, because a lot of times when you start implementing it, you'll have to go get a specific piece of documentation, and it makes that process way less nebulous. It makes it much easier just to get started. Hands-on would definitely be a recommendation there. Getting that documentation for a task specific, that kind of thing.
Yeah, I was going to say the same thing, that especially when you have such a big ecosystem or tools that can be used for so many different use cases, you sort of have to try a few things and find out where the holes in the documentation are, or the holes in your knowledge, because there's just too much. And a lot of these end up being references really, and not a sort of walkthrough of how to do something. So try to find some blogs or other details where people are going through a specific setup, and then try to replicate that yourself. Maybe that'll give you some ideas for other, sort of related tasks. Try doing those. And when you hit a wall, go back to the documentation. In particular for containers, you're right, Docker is a good platform and is widely used, but does have a pretty high level API to it. So if you are curious, just keep checking things out like LXC. I would also say LXD in particular has some decent documentation, and it's a pretty easy to use tool and has a nicer command line interface anyway. So try that. Also play with systemd nspawn, because it's a little different interface to the same technologies, and it might be a good avenue to go sort of poke around in the kernel, the kernel internals, things like namespaces and C groups, and understand how all that actually gets bundled together into a real container runtime.
And that brings us to the end of this week's TechSNAP program. But thank you so much for joining us. If you want more Snap in your life, go to techsnap.systems, where we have past episodes, links to everything we talked about today, and the subscribe buttons. So that way you can get this show every single week. There's a new episode. I've been traveling a bit. Wes has been traveling a bit. We missed you guys. And we always say, whenever you're in doubt, just subscribe and the RSS feed will take care of you. We say that all the time, right, Wes? That's what we always say.
Every week, or just about?
Wes, where can they get more Payne in their life?
Oh, they can find me at Wes Payne on that old Twitterverse, or go find both of us over at Linux Unplugged, another fun podcast to check out on the Jupiter Broadcasting Network.
Yeah, absolutely. I'm at Chris LAS. The whole network is at Jupiter Signal. Thanks so much for joining us, and we'll see you right back here
next week.